Good evening, students. So today again I'm going to discuss about the distance-based method, and the topic is neighbor joining method. We have discussed two topics before this neighbor joining method, that is UPGMA, that is UPGMA and Fitch-Margolis method. They are also the part of distance-based method, and the third method which falls under the distance-based method, that is neighbor joining method. Okay, so in this video we will talk about why neighbor joining is the best method for reconstruction or phylogenetic analysis. We'll understand how it is different from UPGMA method and the Fitch-Margolis method. Then we'll see the steps of neighbor joining method, and we'll solve one numerical based on the neighbor joining method. We'll solve one and we'll do the complete analysis of that numerical, how we are getting the final tree from the distance matrix. So first we'll try to understand how it is different. So let's compare our method. Let me change the color. So first I'm going to talk about UPGMA. So as you know, in UPGMA method, what we were doing, we were just taking the average. Suppose the branch length is the actual distance between two nodes, that is A and B, it is 10. So what we were doing, we were just taking the average. So 10 divided by 2 and 5. So we were doing just A and B, 5 and 5. So this process we were doing in the UPGMA method. Then we discussed about the Fitch-Margolis method. In Fitch-Margolis method, we said, no, we are not going to take the average directly. If A and B is the smallest node, suppose A and B, then if suppose this is the smallest node, then we are going to calculate the actual branch length. And for that, we use the formula, like we have constructed this kind of tree. Then we calculate the branch length of all the three nodes. Okay, so we require minimum 3 nodes, and in that case there is a possibility the A and B branch length, A may be 6, this may be 4, or this may be 8, or this may be 2. So it means the difference between both was that in UPGMA method they were considering rate of evolution is constant. Rate of evolution is constant, while in Fitch-Margolis method it is saying no, rate of evolution is not constant. It may vary. So one branch may go longer, another may shorter, and vice versa. Anything can be done. Now in neighbor joining method does not work on the main matrix. The main matrix means the distance matrix which was given to you, or which you will solve using based on the data. Suppose if you are given with the 10 or 5 sequences, then you will construct this distance matrix. Okay, or you might be given with a distance matrix. So directly what we do in UPGMA, we take the smallest value. Same like in Fitch-Margolis, we consider the smallest value. But neighbor joining method says no, this is not the nearest value. You first construct a new matrix, new distance matrix. How we will do that I'll show you when I'll solve the numerical. And from that distance matrix, you need to find it out the smallest value. So that is the difference between all these three methods. So if I'll compare all of these things, if I compare UPGMA, Fitch-Margolis and neighbor joining method, this is the very basic or simple method. This is the complicated method. This solution, when I'll solve this numerical, then you will understand why it is little bit difficult, because you have to do lots of iterations and lots of calculation. Fitch-Margolis method is the advanced method of UPGMA, and neighbor joining method is the advanced version of Fitch-Margolis method. Okay, so I hope you will get the little bit idea about what is neighbor joining method. Neighbor joining means it is going to find out the nearest neighbor. Who is my nearest neighbor? And that too on the basis of the rate of evolutions. Okay, we'll identify the rate of evolutions, how far it is evolving. We will focus very much, we will focus on our neighbor. Neighbor means suppose you are having 3 value, so you will try to focus on this and this value. So that things we will discuss in neighbor joining method. Now let's talk about the steps of neighbor joining method. So it contains lots of steps, like if you have remember the UPGMA or Fish-Margolis, I'll share the link also of those videos that you can see if you have not seen yet. So first you will start with the distance matrix, means either it will be given or you can create using the formula. Then you need to calculate the modified distance matrix. From that steps you have to identify the closest pair, means these steps we were not doing in the previous methods. So in neighbor joining we will do this step also, means we will calculate the modified distance matrix. Then we will create a new node, we will calculate the branch length, calculate remaining distances and update the distance matrix, and you will repeat this process multiple number of times. So these steps, all steps are the same what we were doing the previous methods, but here it is little bit different. First, in the concept of like you have to construct one new matrix. Here for the calculating the remaining branch distance also little bit different, so that we'll see when we'll solve the numerical. So let's start with the solution of this method. So this is a numerical. Let's see, this is example is given to you, and we have to construct the phylogenetic tree using this distance matrix. So there are 5 nodes, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and this is the distance matrix. You might be seeing there is a one extra column is given. Okay, so this is not a mistake, it is by knowingly I have kept here, because as I said before, we have to calculate the rate of evolution, means we have to focus on our neighbor. Until or unless we are not focused on our neighbor, we will not solve the neighbor joining method. So we are trying to connect our neighbors. So let me change the color for this. We are going to calculate Ri, this rate of evolution or rate of mutation, whatever you can say. We have to calculate this. So I am writing this value from the red color. So that is Ri. So how you will calculate this value? So now we have to calculate all these values. Okay, so let's first see how we will solve this method. I'm writing the formula and we'll do this. So again, let me change the color for Ri. So how to calculate the Ri? So what is Ri here? So R, you know, it is a rate, or it is you can say some, it is not basically that rate or something. You can imagine like we are going to connect our neighbors here. Okay, so what is this I? I is the nodes. And how many nodes you have in this method numerical? 5 nodes. That is A, B, C, D and E. It means you have to calculate this R 5 times. RA, RB, RC, RD and RE. We have to calculate this in this manner. Okay. Suppose you are given with a small numerical like ABC only, then you have to calculate only RA, RB and RC. So what is I? I is the node, and these are the nodes in this numerical. These are the nodes. Okay. I hope it is clear. So let's see what is the formula for this. So for Ri, the formula is, or we can say like in case of Ra, like Ra, we can say AB plus AC plus AD plus AE. Means I am trying to find the connecting all the nodes from my parent node. For RB, BA, BC, BD, BE. Same like RC, CA, CB, CD, CE. Same like for D, CD, DA, DB, DC, DD, DE. Then RE, EA, EB, EC, ED. Okay. So this is the formula for R calculation. So here we are calculating RI. So let's calculate RA. I will do one, rest you will do. I will write the values, rest you will do it. Okay. So RA in case of this, it is 4 plus 5, AC is 5, AD is 2, AE is 3. So it is 5, 4, 9, 9 to 11, 11 and 3, 14. So likewise you will do all this calculation. You can pause this video for a minute and you can solve all these value and you can cross check your identified value with the solution which I am going to put here. If you have any further doubt, you can drop your doubt in the comment. I'll revert to you. So here we will get, so this value is 14. RB is, this is 25. This one is 19. This one is 17. And this one is 21. There is a one more simple method. If you do not want to do this calculation, you can solve in your mind and you want to write, then it's very simple. When you are calculating for A, just count, add all these value. When you are doing for this B, count this and the one value above this line 0. For C, these two, the value above this 0. For D, this value, the value above this 0. And for E, all these value. So if you want to just cross check here, for 14, 3 to 5, 5, 5, 10 and 4, 14. For B, 8 and 6, 14, 14, 7, 21, 21 and 4, 25. 4, 3, 7, 7, 7, 14 and 5, 19. So this is the way of calculating R. So this was my first step. This is our first step we have done here. That is, we have calculated RI value. Now what we have to do is, once you have calculated RI, now you have to calculate this step. Means you have to calculate the modified distance matrix. Now if I am denoting this matrix with the D, then the new matrix I am going to denote with D dash. So we have to calculate the D dash value. Let me draw this value. So it is A, B, C, D, E. So A, B, C, D, E. A, B, C, D, E. So the diagonal value will be 0. Now we have to calculate this value. So what is the formula for calculating the D dash? So whenever we are calculating these values, so these values are in between two nodes. So you can say, suppose you are calculating this value. So this value is in between A and B. Okay. Likewise this AC, AD, AE. So this we have to calculate. Okay. So the formula for D dash IJ equals to Dij minus Ri plus Rj divided by n minus 2. So let's understand this formula. What is this formula? So we are calculating D dash. So this is our D dash matrix. D dash Ij. Ij means what node? Here also I is node, J is also node. So it is the connecting node. Connecting node means these are like AB, AC, AD, AE. For B, BA and AB is the same. Okay, so we have to calculate BC, BD, BE. Same like CA, AC is same, CB and BC is same, so we have to calculate CD and CE and DE. So these 10 values we have to calculate. So let's understand this for as one simple thing, D dash AB. I will calculate one, rest I will write, I will pause the value, I will pause the video, I will write by own. So you will solve by your own, okay? Don't just copy it, just solve all the value. So I am calculating for D dash AB. So here what will come? DAB minus RA plus RB. N, what is the value? What is N here? N is node. So how many nodes we have here? 5. 1, 2, 3, 4, 5. So here node value is 5. So RA plus RB divided by 5 minus 2. Now let's put the value DAB. So this is D matrix. So DAB value from where you will get? You will get from this matrix. This value we are calculating for D dash AB, we are calculating this. But for this value you will get from here. So DAB is what? DAB is 4. 4 minus RA. What is RA? This one is RA. A. So it is 14 plus RB. RB is 25 divided by 5 minus 2 is 3. So 4 minus 5, 4, 9 and 2, 1, 3, 39 divided by 3. So this will be 13. So 4 minus 13 equals to minus 9. So this value, different color. So this value will be minus 9. So likewise we have to calculate all these values. So just pause this video and solve all the calculations. Like you have to calculate you have to calculate D dash AB, we have calculated, D dash AC, D dash AD, D dash AE, D dash BC, D dash BD, D dash BE, then D dash CD and D dash CE and D dash AB, BC, CD and DE. So all these values you have to calculate. Just pause the video here, calculate all these values. This one we have calculated, that is minus 9. Okay, so just do all these calculation and cross check with your results. I'm filling into the matrix. So by using the same concept, you will get the detail of all the values. So I'm filling into this matrix, which is the color. So it will be minus 9, minus 6, minus 8.3, minus 8.7, minus 7.7, minus 8, minus 7.3, minus 9, minus 9.3 and minus 6.7. So this is the D dash value matrix we have calculated. Now what we have to do, we have to identify the smallest value. So let's check or let's understand why we are doing these many calculations in neighbor joining, which we were not doing in the previous numericals like UPGMA or Fish-Morgolish. If you see the D matrix, this D matrix, you will see the smallest value is 2. And it is in between A and D. A and D is smallest value. So if we start solving the numerical directly from this matrix, we will take AD as a common node. Means when we will make a tree, we will take AD as a common node. Okay. But in neighbor joining, we are doing this all calculation like Ri we are calculating and we are calculating D dash matrix. So now here you have to see the smallest value and you will find which one is the smallest, because all value is negative. So the highest number will be the smallest. So you will see here the smallest value is CE. The smallest value is CE is smallest value. So if you'll make tree, that node will look like CE. This is the difference in neighbor joining method, and this is the more accurate method. Till date it is used widely. Okay, so this is a very accurate method. I hope you are understanding what we have done here. So just I hope you have calculated all these values. Okay, or if you have any doubt, just put your comment in the comment box. I'll revert to you, and you can watch this process again and again. We are calculating d dash ij, dij minus ri plus rj, like when we are calculating. So now we have identified the smallest value, and that is CE. That is CE. So let's start the calculation part. So CE is the smallest value. So now what we have to do is we have to make a tree like the same we were doing in the Fitch-Margolis, CE, and rest connecting one we are considering as U. You can make it as X, W, Y, whatever you want to make, you can. Now we have to calculate the branch length, means branch length of C and branch length of E. We have identified, see here, if you'll see here, we are not going to use any of these value in our calculation. None of the value from D-dash matrix we are going to use. Only and only we are just doing this calculation to find it out the smallest node. Okay, so here we have identified C and E are smallest and the value is minus 9. Now we are going to 9.3. Now we are going to calculate the actual branch length. So branch length of C and E. So what is the formula for branch length? Okay, so the formula is branch length, or you can say like D or whatever you want to take. Let's say branch length only. Branch length equals to 1 by 2 Dij plus Ri minus Rj divided by 2 n minus 2. So this is the formula. Don't get confused with the formula. If you'll see the previous formula here, d dash calculation, d dash ij, dij, here is we are not dividing by anything, and here we are adding an n minus 2. Here what is the difference? 1 by 2 dij plus ri minus rj divided by 2 n minus 2. So be very careful. So now we are calculating the branch length for C. Let's see branch length of C. 1 by 2 dij, ij is CE, plus RC minus RE divided by 2. What is n? N is 5. 5 minus 2. Okay, so let's see 1 by 2 DCE. Now let's check the value of CE. CE value is 4. CE value is 4 plus RC. RC is 19. RC is 19 minus RE. RE is 21. RE is 21 divided by 5 minus 2, 3. 3 2 6. So let's cut this. So it is 2 plus 19 minus 21. So it will become minus 2 by 6. So it will become 1, 2, 3 6. So this is equals to 2 plus minus 1 by 3. So if you will solve this minus, this will become 0.33 something, 33333. Okay, so just what we will get, 1.7. Okay, so it will plus, when you will open the bracket, it will become minus, this value is 0.3, so it is 1.7. So we have calculated branch length for C. So C value is 1.7. Now we have to calculate for E also. So branch length of E equal. So it is very easy. The total C and E, the total C E is 4 and C is 1.7. So how much it is left? 4 minus 1.7, that is 2.3. So E is 2.3. Clear? No need to calculate for you. Only we have to calculate for this. We will calculate automatically in the when we will solve the numerical further. We will calculate this. So what we did in our first iteration, this was the matrix which was given to us. We calculate the Ri. Ri is very simple. This is the formula. Then we have calculated D dash. That is, we have calculated our D dash matrix 0 minus 9 minus 6 minus 8.3. So this value we have calculated using this formula. D dash ij equals to dij minus ri plus rj and minus 2. Okay. So this is the formula we use to calculate this matrix. Once we have calculated this matrix, we find it out the smallest value. Which one is the smallest value? Once it is done, we identified the node, it is C and E. It was C and E. So we calculated the branch length of C and E. And the formula for branch length is this one. Okay. By using this formula, we have calculated branch length for C and branch length for E. We have calculated these two values. Now again come to your steps part. Find the closest pair. Create a new node. So we have created new node, that is CE or U. So we have created this CE and U. Calculate the branch root length. Calculate remaining distance. Means again we have to update the distance. Calculate the remaining distances and update the distance matrix. So now we have to update the distance matrix. It means our CE, and CE is nothing but U here. So CE become a common node. So now we'll converge our matrix. It is A, B, D and U. And what is U? U is nothing but CE. U, A, B, D. So again we have to calculate this matrix. We have these value available in the previous matrix. So if you'll see AB and AD, so AB is 4, AD is 2. So AD is 4 and 2. BD is also available. BD is 6. BD is 6. These values are not available. So we have to calculate. So if you remember in our UPGMA and Fitch-Margulies method, what we were used to do, we just take A to C and A to E. Yes. And we just take the average. Here it is little bit different. Here along with the taking the average, so let's calculate UA. So UA, the formula for UA is A to C plus A to E minus CE divided by 2. This part we were not doing there. So let's see what is the value of AC. AC is 5 and AE is 3. AC is 5, AE is 3 and CE was 4. If you remember here, CE was 4 and CE was 4 divided by 2. Okay, so this will become 8 minus 4 divided by 2. 4 by 2 equals to 2. So this value will be 2. Now calculate UB and UD. Pause the video, solve this UA and UD. I'll wait here. So you can do this. So I am just writing the value. The formula is very simple. Again, I will write the formula. BC plus BE minus CE divided by 2. DC plus DE minus CE divided by 2. So the value which you will get here, that is 5.5 and 2.5. So once you have calculated all these things, then again we have to restart the process. The same process what we have done till yet. Now the same thing we have to repeat by using the same thing. So what we have to do first, again we have to calculate the Ri value. Means we have to calculate the Ri value. So this Ri, the formula is very simple. So U Ri means Ri, in place of I it will be Ru. So what it will be? 5.5 plus 0.56, 6 to 8, 8 and 2, 10. 4 to 6 and 8. 6, 4, 10, 10, 15.5. 6 to 8, 8 to 10, 10.5. So if you have any doubt in calculation of Ri, just go back in the video. You will get the idea how we are going to calculate the Ri. Okay, so that data you will get from there. Okay, so now when we have calculated the Ri, now again we have to calculate the D dash matrix. So now this matrix will become as a D matrix. This is the D matrix. Now we have to calculate the D dash matrix. So again U A B D, U A B D, now we have to calculate the UA. Okay, so now we have to calculate the D dash UA. So D dash UA equals to, again the formula is same, DUA minus RU plus RA divided by N minus 2. Sorry. So DUA we have seen here, it's a 2 minus RU is 10 plus RA is 8. Now N value is changed. It is not fixed in the throughout the numerical. Here we were using N value is 5 because A, B, C, D, E, 1, 2, 3, 4, 5 nodes were there. But now if we'll check here, 1, 2, 3, 4. Now N value will become 4. So 4 minus 2 is 2. So the value is 2 minus 10 and 8, 18. 18 divided by 2. So it will become 9. So 2 minus 9 equals to minus 7. So likewise you need to calculate D dash UB, D dash UD, D dash AB, D dash AD, D dash BD. So you have to calculate all these 6 values. So let me fill this value. So this value is minus 7. Now just pause the video and calculate all the values like D dash UB, UD, AB, AD and BD. And if you have any doubt, just go back to the starting part of the video. You will get the idea how we are calculating this. So I am writing these values here. So it will become minus 7.25, minus 7.75, minus 7.75, minus 7.25 and minus 7. So you will see here we will find two values, all three values are like we have 2 minus 7 minus 2.5 two times and minus 7.25 two times. Okay, so we have such kind of values. So you can take any value which you think is the smallest. So whatever value you want to take, I think this is also come. So this is also minus 7 point. This is also 7.5 only. It's not 25. It's 7.5 only. All values are same. These all four values are same and two values are minus 7. Okay. So you can take any value as the smallest value. Just a minute. I think I have made some mistake here in the calculation. Let me check. Just a second. Yes, this is 2.5 only. Okay. And this is also 2.5. The previous value was right. I think I did some small silly mistake, so that's why it got disturbed. Okay, so now we have 2 minus 7, 2 minus 7.25 and 2 minus 7.75. So here if you'll see these two value UD and AB both are same. So either you can start with UD or you can start with AB. Wherever you want to start you can go with that. Okay, so now here I am taking AB as the smallest one. So let me highlight it with different color. I am going with this node. I am going with this node. I am considering AB is the smallest node here. But again, if you want to cross check both the matrix, if you'll see here, we have sorry, we have UA and UD. UA and UD. Sorry, AD. We have UA and UD. These two value are the smallest, but no, actual value is AB. This value is the smallest, though it is the very large value in this matrix, but in D-dash matrix, this one is the smallest one. So now again, what we have to do is we have to calculate the branch length. We have to calculate the branch length. Branch length of A and B. Previously we have named as U, now I am naming as U1. So if you calculate the branch length of A, so the formula is very simple, 1 by 2 Dij, I am writing the formula, plus Ri minus Rj divided by 2n minus 2. So we are calculating for A, so it is 1 by 2 AB, DAB plus RA minus RB divided by 2. Again, and you should remember it is not 5 now, it is 4. 4 minus 2. So if we see here 1 by 2 DAB, what is the value AB? AB value is 4. AB value is 4. So DAB is 4 plus RA and RB. RA is 8, RB is 15.5. It's 8 minus 15.5 divided by 4 minus 2, 2 2s are 4. So 1 by 2, 4 plus 8 minus 15.5. So it will become, and here it is divided by 4. So if we'll calculate this, so it will be like 0.5 minus 7.5. So if we divide by 4, it will become 1 point minus 875. Okay, so here it is. So here value will come minus 1.875. So this will 2. So 2 minus 1.875. So it will become approximately. So if you round it off by 9, 1.9. So 2 equals to 2 minus 1.9, because it will 8 and 8, 8, 8, 9. So you will get 0.1. So A value is 0.1. Now branch length of B equals to 4 minus 0.1. So it will become 3.9. How I did it? It is very simple. So A and B total distance was 4. How I get this? From this matrix. AB value is 4. Now A is 0.1. What is rest remaining? It is B, and B is 3.9. So we have calculated A and B branch length here. So now what we have to do is we again need to converge the matrix. Means now our AB, what was C? What was U? It is CE. Now AB is become a common node and it is named as U1. So what we have to do is we are going to make another matrix, that is U, U1 and D. U, U1 and D. Okay. So now we have to calculate the U to U1. Means we are calculating CE to AB. We are calculating this distance. So CE was already U. So how we will, so let's calculate for UU1. UU1. If I'll calculate, the formula is UA. U is already CE because we have this U in our matrix. So U to A, U to B, U to A, U to B minus AB. So U to A plus U to B minus AB divided by 2. So UA is 2, UB is 5.5 minus 4 divided by 2. So it will become 7.5 minus 4 divided by 2. 3.5 divided by 2, it will become 1.7. So this value is 1.7. Now pause the video and do this all calculation. So these value will be 2.5 and here it will be 2. So now our new matrix is again ready. What we do it here? For the next iteration, again we have to calculate the Ri. Again we have to calculate the Ri. So what is Ri here? Again the formula is simple. For Ri, 2.5 and 1.5 we have to just add this. So 0.2, which is the color. So what it will be? It will be R like U1 plus UD equals to Ri. So it is, so it will become 4.2. This will become 4.2. Now this will become 2 and 1 3.7. This one will become 4.5. So this is the Ri we have calculated. Now again we have to calculate the D dash matrix. We have to calculate the D dash matrix. So for D dash, the formula is again similar as we have discussed in previous iteration. It is U, U1 and D, U, U1 and D. These values are 0 and the D dash I am calculating one, rest you will calculate. UU1 equals to DUU1 minus RU plus RU1 divided by N minus 2. Now just drop your comment when you solve this. What will be the value of u here? Okay, just I will tell you, but you drop it. Pause the video here itself, then calculate, drop your comment, and then continue watching this. So you will get the idea of what is happening here. Now n value will become 3. Why? It is u, u1 and d. Only 3 nodes are left. So if you let's keep 3 here in spite of, or let it be n minus 2 for your sake, and you can write here 3. So if I'll calculate u1 is 1.7 minus ru is 4.2 plus ru1, it is 3.7, divided by 3 minus 2, it's become 1. So 1.7 minus 7.9. So this will become minus 6.2. So likewise you need to calculate d dash ud and d dash u1d. So just pause the video, do this calculation. I am writing here, but you just do it by yourself, and if you have any doubt, just drop your comment. So these values will be minus 6.2, minus 6.2, minus 6.2. So all these three values are same. Okay. So now what we have to do is we have to go for the next step. Means we have to find it out the smallest value. So all value are the smallest. You can go with any value. I am going with u and d as a smallest value. This one. U and D as a smallest value. Okay. So we will continue with the u and d. So we'll construct a tree like u and d, and then we'll give the name as u2. But first we gave u, u1 and u2. So now we have to calculate the branch length of u and d. So let's calculate the branch length of d. So what is the formula for branch length of d? D du, I'm just writing that directly, divided by 2. It is nothing but it's like 1 by 2 only. 1 by 2 d du plus rd minus ru divided by 2 n minus 2. So 1 by 2 d du 2.5. So it is 2.5 plus rd. What is rd? 4.5. rd is 4.5 minus ru. ru is 4.2. 4.2 divided by 2. N value is 3. 3 minus 2. So it will become 2.5 divided by 2 plus 4.5 minus 4.2. It will become 0.3 divided by 2. So it will become 1.25 to 1.25 plus this will become 0.115. So it will become 1.4. So d value is become 1.4. Now total ud value, u and d is 2.5, in which your d value is 1.4. So what is the u value? It's very simple. 2.5 minus 1.4, that will become 1.1. So this is 1.1 and this is 1.4. So now again what we have to do is, again we have to converge the matrix. So now what you will converge? See here, in this UD combinedly is become U2. So now just see a little bit here. Let's discuss a little bit. The first node which we made, that is CE, we gave name U. The next we made AB with the U1. The next we made UD with the U2. It means this U2 is the combination of this one along with this one. You can draw like this. This combinedly is U2. So this node I have denoted here with U. Let me change the color. I think that will find better. So this complete node I have merged here. So now when we are going to converge the matrix, we will converge between U1 and U2. U1 and U2. U1 and U2. So how you will do this? The process is again same. What is U1? U1 is A and B. What is U2? U and D. And what is U is C and E. Okay. But in this matrix you have U. U is available, D is available. Okay, in this matrix. U is available, U1. So you have to calculate U1 and U2. U1 to U2 distance you have to calculate. U1 to U2 distance you have to calculate. So the same formula you will use. What you will do here? We have to calculate U to U1, U to U1 here. U1 plus DU1 minus U1 U2 U1 U2 divided by 2. So UU1 is 1.7 plus DU1 it's 2. This is 2 minus U1 U2. U1 UD, sorry, we are calculating UD only. So here it is not U1 U2, it is UD. I'm marking it with red color because it is U and D only. So it is minus UD. So UD is 2.5 divided by 2. So this will become 3.7 minus 2.5 divided by 2. So it will become 1.2 divided by 2. It will become 0.6. So this value will be 0.6. Now if you'll see here, now what you have to do is, if you'll see here n value, you might be think like what to do this. Do we have to go for next step? Because we have converged, we have to calculate Ri. So if you calculate Ri here, what you will get? You will get 0.6 because you only have one value. So there is no purpose of calculating Ri. Now if you want to calculate D dash, let's see, I'll show you the formula. If you want to calculate the D dash, you have to do, what you have to do is n minus 2. And now what is the value of n here? N value is already 2. So 2 minus 2 will become 0. So when the value is 0, and if you will divide here, something by 0, you will get 0. So there is no purpose of continuing further. It means our process is completed here. Now what we have to do is we have to calculate our tree. We need to calculate our tree, which we have not calculated yet. So how we will calculate? So bring all the tree here first. So the first one was CE, U. The second one was AB, U1, and then UD, U2. what is the value, what all values we got. And the first tree was CE 1.7, 2.3, 1.7, 2.3, and for AB we got 0.1, 3.9, 0.1, 3.9, and for UD we got 1.1 and 1.4, 1.1 and 1.4. So this is the value we have got. Now we have to merge this tree. So if you merge this tree, you will find, like, first start with CE. So this is C, this is E. So C, E. C is 1.7 and E is 2.3. Distances vary. Now this is your U. Now we have to merge over here. U, if you'll see here, U is connected with D. U is connected with D. So let's mark here. Let's mark here D, and D is 1.4. D is 1.4 and this one is U. U is also connected with D and it is also connected to U2. So this one is your U2. Now again come here. Now U2 is what? U and D. Okay. So it means you are going to merge this tree here with U1. So this is your U1. This one is your A and this one is your B. A is 0.1, B is 3.9. Now what is these value? So now again come here, come back. You have already calculated, that is 1.1. If you remember in Fitch-Margulies method, we were calculating this value, which automatically you have already calculated here. Okay, and this one was your U1. And U1 to U2 distance you have just now calculated in your last matrix, U1, U2, and that is 0.6. So this is my final tree. This is my final tree using neighbor joining method. So this is the complete process. I have shortened it because if I'll go with all the calculation, this video might be go for 1.5 hours. It will take lots of time. So I'll just summarize it. So you will be given, or you will have to start with your distance matrix. First you have to calculate the Ri. Then you have to calculate the D dash matrix. You have to find it out the smallest value. This D dash is only and only for the finding the smallest value, the smallest node. Once you will identify the smallest node, then again you have to calculate the branch length. Once you will calculate the branch length, converge the matrix, making this one as a common node. Okay. Then again calculate the Ri, again calculate the D dash matrix and calculate the branch length. Once you have done with all the things, just merge them all together and you will get the final tree. So this is about the neighbor joining method. If you have any kind of doubt, just drop your doubt in the comment section. Thank you everyone. Thank you for patiently watching. If you have any query or any comment or anything to ask about this method, you can just post your comment in the comment section. Thank you everyone.